Whoa, big question. Nothing to worry. Let's see the question. For each natural number k, let ck denote the circle with radius k centimeter and center at origin. On the circle ck, a particle moves k centimeter in the counterclockwise direction. After completing its motion on ck, the particle moves on ck plus 1 in the radial direction. The motion of the particle continues in this manner. The particle starts at 1, 0. If the particle crosses the positive direction of the x-axis for the first time on circle Cn, then n is equal to what? See, it looks like a complicated situation, but it is not. If you draw the diagram, you will realize that this particle, that first of all, there is a bunch of concentric circles, okay, of radius 1, 2, 3, etc. And the particle starts at a point 1, 0, and then on the first circle, the particle moves 1 centimeter. Then it moves on to second circle. On the second circle, it moves 2 centimeter. Then it moves to the third circle. On the third circle, it moves 3 centimeter, which is exactly what the question is saying, that it moves k centimeter on ck and then it moves to k plus 1. All right. So what the question is asking is that when the particle follows this path, when does it reach the x-axis again? Okay. So we need to figure out when does the particle reach the x-axis again, right? So the first and most important observation here is that in each circle, the particle only moves 1 radian. Why is that so? Because the distance moved on ck is k centimeter, right? And the radius of ck is also k centimeter. So on every circle that has the radius k centimeter, the particle moves a distance of say k centimeter. So if you realize, the angle moved by the particle is actually k centimeter upon k centimeter using theta is equal to L by R. And therefore, on every circle, the angle moved is 1 radian only, right? And so on every circle, it moves 1 radian, right? So first circle 1 radian, second circle 1 radian, third circle 1 radian. So when will it reach the x-axis again? It will reach the x-axis again when it has finished how many radians? Yes, 2 pi radians, right? 2 pi radians, which is the angle of the complete circle. And so how many radians are there in 2 pi? In terms of numbers, it should be 6.28, right? 6.28, because pi is approximately 3.14. Therefore, 2 pi is approximately 6.28. And we know that the particle will reach the x-axis when your nth circle has a value that is greater than 2 pi, right? So 2 pi itself is 6.28, and so your n must be 7. Did you figure that out? See, on the third circle, the particle is covering third radian. So on the fourth circle, it will cover fourth radian, and so on. So on the sixth circle, it will cover 6 radians. And while it is on the seventh circle, it would be crossing 6.28 radians, right? And so on the circle, seventh circle, the particle will cross the x-axis. Got it? Interesting question, right? It might look a little bit complicated, but when you realize what the questioner is asking, you see the solution is smaller than the question itself. Okay? All right. Let us proceed. If sec A plus tan A times sec B plus tan B times sec C plus tan C is equal to tan A, tan B, tan C, then sec A minus tan A times sec B minus tan B times sec C minus tan C is equal to what? Okay, again this looks a little bit complicated, right? Because if you know sec A plus tan A times sec B plus tan B and so on, how do you change the entire product, right? So what we will do is we will first reach each bracket individually. Okay, we will say that since we know sec square A minus tan square A is equal to 1, therefore I can say sec A minus tan A is actually inverse of sec A plus tan A. Is that right? See, the product of sec A minus tan A and sec A plus tan A is 1, right? And so sec A minus tan A is 1 upon sec A plus tan A. And therefore I can say sec b minus tan b is 1 upon sec b plus tan b, and sec c minus tan c is also 1 upon sec c plus tan c. And so when you multiply all of those, you get sec a minus tan a times sec b minus tan b times sec c minus tan c is actually equal to sec a plus tan a into sec b plus tan b into sec c plus tan c, the whole inverse, right? And if you see, the RHS is already given to us. We can say RHS then becomes tan A into tan B into tan C, the whole inverse. And what is that inverse? It is simply cot A times cot B times cot C, right? And so your sec A minus tan A into sec B minus tan B into sec C minus tan C is cot A, cot B, cot C, right? And so fairly simple, right? Once you realize that the useful identity here is sec square A minus tan square A is equal to 1. In fact, can you recall that we have used this property very similarly a few questions ago? When we had a question between cosec theta and cot theta, we used the same identity in a very similar fashion. So you see, this is a very basic identity, but it can be very useful when the situation calls for it. Okay? All right, let us move on. If A, B, C, D are angles of a cyclic quadrilateral, then cos A plus cos B plus cos C plus cos D is equal to what? Okay, the options are right here. Let's see. We know that the opposite angles of a cyclic quadrilateral are supplementary, right? That means angle A plus angle C is pi and angle B plus angle D is also pi. Okay, so then can I say that cos A plus cos B plus cos C plus cos D is equal to cos A plus cos B plus cos of pi minus A plus cos of pi minus B? We can say that, right? Because I'm simply replacing C with pi minus A and D with pi minus B. But what is cos of pi minus A? You have studied allied angles, right? So what is cos of pi minus A? It is simply minus cos A, right? Because cos of pi minus theta is minus cos theta. And therefore your entire RHS then becomes cos A plus cos B minus cos A minus cos B, which then everything cancels out and then you get a nice and happy 0, right? And therefore your answer cos A plus cos B plus cos C plus cos D is 0, whatever the quadrilateral might be, as long as it is a cyclic quadrilateral, right? So you see, we have solved a completely geometry question using basic principles of trigonometry, right? Okay, let us proceed. Sine square 5 degrees plus sine square 10 degrees plus sine square 15 degrees all the way up to sine square 90 degrees. What is it equal to? Okay, let us, do you remember that we have solved a similar question before, right? But there it was tan and there it was 1 degrees, 2 degrees, etc. But you see, we can use a similar process here. Okay, what we can do is that in this, you try to bring complementary angles together once again, right? So I can write it as sine square 5 degrees plus sine square 85 degrees plus sine square 10 degrees plus sine square 80 degrees all the way up to sine square 40 degrees plus sine square 50 degrees, right? And then there is a sine square 45 degrees separate, and then there is a sine square 90 degrees separate. Now look at each of these brackets, right? What you have is sine square theta and then sine square 90 minus theta. Can you see that? Every bracket has sine square theta and sine square 90 minus theta. What is sine 90 minus theta? Cos theta, right? So what we have here is every bracket has sine square theta plus cos square theta. Every bracket. So each bracket we know sine square theta plus cos square theta is 1, and therefore in every bracket it becomes 1 plus 1 plus 1 and so on, right? All the way up to when we reach sine square 45, it is 1 by root 2 the whole square, and sine square 90 is 1. How many brackets are there? How many ones do we get, right? You have to be very careful here. See, we are starting with sine square 5 degrees, and with multiples of 5, we are reaching 40 degrees, right? So how many multiples of 5 are there in 40 degrees? It is 8 multiples of 5, right? And therefore, in the bracket here, we should have 8 ones, and then a 1 by root 2 the whole square, and then a 1, right? And so this total should turn out to be 8 plus 0.5 plus 1, which is 9.5. Got it? The answer is 9.5. Okay. All right. If sine 120 degrees minus alpha is equal to sine 120 degrees minus beta is equal, where alpha and beta lie between 0 and pi, then the relationship between alpha and beta could be what? Okay. Whenever you see a question that says could be, you should know that maybe more than one answer is correct. Now, JEE Main does not give you more than one correct answer type questions, but JEE Advanced does it. Okay. So don't worry, you will get enough practice to deal with such questions. All right. So if sin A equal to sin B, where we are writing A as 120 degrees minus alpha and B as 120 degrees minus beta, what can we conclude? Think about it. Whenever you have sin A equal to sin B, I can simply say that angle A could be angle B, right? Or you can have angle A and B are supplementary angles, right? Because let us say 60 degrees and 120 degrees. What is sine 120? What is sine 120 degrees? We know that 120 degrees is 180 degrees minus 60 degrees, and therefore sine 120 degrees is simply sine 60 degrees, because sine of pi minus theta is simply sine theta, right? And so we can conclude that if sine A equal to sine B, then either A equal to B or A equal to pi minus B, that is A plus B is pi, right? And therefore I can say that 120 degrees minus alpha is equal to 120 degrees minus beta, or 120 degrees minus alpha plus 120 degrees minus beta is equal to 180 degrees, right? When you simplify both, you will get either alpha is equal to beta or alpha plus beta is equal to 60 degrees, right? Just a matter of simplification. Often you get equations like these in this question. You will solve many such questions later when you do trigonometric equations. But just this basic, since you know that sine 180 minus theta is sine theta, we are going to use that property to solve such questions, right? Did you get that? All right, let's proceed. If alpha lies between pi and 3 pi by 2, then root of 1 minus cos alpha upon 1 plus cos alpha plus root of 1 plus cos alpha upon 1 minus cos alpha is equal to what? This is a very interesting question, because here alpha does not lie in the first quadrant. Alpha lies in the, which quadrant is it? It is the third quadrant, right? So alpha lies in the third quadrant. Let us see how does that change your method of solving. We know that the given expression root 1 minus cos alpha upon 1 plus cos alpha plus root 1 plus cos alpha upon 1 minus cos alpha can be written as, when you cross multiply the terms, you get 1 minus cos alpha plus 1 plus cos alpha, and in the denominator you have root 1 plus cos alpha into root 1 minus cos alpha, root 1 minus cos square alpha, right? And in the numerator, if you see a minus alpha and plus a minus cos alpha and plus cos alpha will get cancelled, and in the numerator you have 2, and in the denominator I have, what is it? What is 1 minus cos square alpha? Sine square alpha, right? Okay, so we have 2 upon root sine square alpha. Now before you say that root sine square alpha is equal to sine alpha, let me caution you, that is not always the case. Root sine square alpha is actually equal to mod of sine alpha. Wait, how did we get a mod here? Now think about it. If I have root minus 1 the whole square, yeah, think about it, root minus 1 the whole square, what is it? Can I simply say the root and the square cancel off and I get minus 1 as the answer? That's not correct, because then what is root of 1 square? That, if by following your logic, it would be 1, right? But we know 1 is not equal to minus 1, correct? So whenever you get a square root of a perfect square, you should not simply cancel the square root and the square. You should always put a mod outside. What it means is that the final answer is positive. What you want is the final answer to be non-negative, which is why we take a mod, which means square root of 4 is always 2. It can never be minus 2, right? So similarly over here, when we have square root of sine square alpha, we can say it is mod sine alpha, right? Okay, so what we have here is 2 upon mod sine alpha. Now what do we do with mod sine alpha? Can I simply say mod sine alpha is sine alpha itself? Think about it. No, not in this question, because in this question alpha lies in the third quadrant, right? Alpha lies in the third quadrant, and in third quadrant sine alpha is actually negative. Since sine alpha is negative, we have 2 upon mod sine alpha, which simplifies to 2 upon minus sine alpha, since alpha is in the third quadrant, and therefore your answer is B, minus 2 upon sine alpha. Interesting question, right? JE will often have these kind of small traps where it is easy to fall into if you're not 100% clear with the concept, right? And so the takeaway from this question is that square root of a perfect square is not the number itself, but it is the absolute value of that number. Okay. All right. So let's proceed. The greatest value of sine raised to 4 theta plus cos raised to 4 theta is what? Now, J loves to give you functions in theta or in other variables and to ask what are the possible values taken by these functions. This is one such question. Okay. Now we know that a square plus b square is actually a plus b the whole square minus 2ab, right? We can write it like that. So over here we have sine raised to 4 theta plus cos raised to 4 theta, which again then write is sine square theta plus cos square theta the whole square minus 2 sine square theta cos square theta. What I have done is taken a to be equal to sine square theta and b is equal to cos square theta. So if a is sine square theta and b is cos square theta, I have a square plus b square, which I've then written as a plus b the whole square minus 2ab. That is sine square theta plus cos square theta the whole square minus 2 sine square theta cos square theta. Okay, which I know then simplifies to 1 minus 2 sine square theta cos square theta, right? Because sine square theta plus cos square theta is actually equal to 1. So we have 1 minus 2 sine square theta cos square theta. Now think about it. This entire expression, which values can it take? You see, there is a minus 2 sine square theta cos square theta. Now sine square theta into cos square theta is a perfect square, right? Which means it has to be non-negative, which means it can be either be 0 or positive, right? And 1 minus double of that number, do you realize, will always be 1 minus a positive quantity, right? 1 minus a positive quantity, which means this entire expression is always less than or equal to 1. Less than or equal to 1. It could be equal if sine square theta into cos square theta is 0. If that turns out to be 0, then we have 1 minus 0, then equality is valid. Otherwise, 1 minus 2 sine square theta cos square theta is always less than 1. Therefore, we have the equality being valid whenever sine theta or cos theta is equal to 1. Therefore, we have the given expression to be less than or equal to 1, which is your answer, right? So, the greatest value is 1. Now, keep in mind that often when you as you proceed, as you learn more of trigonometry and even differentiation, you will learn other methods of finding greatest or lowest values of functions. But basic identities like these that you have learned all the way up even in 10th standard can also be very useful in solving such questions, and often these identities will get you the answer faster than some advanced methods that you will learn later. Okay, all right, let's proceed. Sine raised to 2nx plus cos raised to 2nx lies between what, right? Okay, again another question which is entirely dependent on n. Now we know that sine raised to 2nx must lie between 0 and sine square x, and cos raised to 2nx must lie between 0 and cos square x. Hold on. Why should that be the case? Because think about it. Sine x is a small value, right? It lies between minus 1 and 1. And if we take sine square x, which is a positive value, it will even lie between 0 and 1. Correct? It will lie between 0 and 1, which means it's a small fraction. Which means if I take sine x to be positive, then every higher power of sine x is smaller than the previous power. Correct? Which means I can say sine x is greater than or equal to sine square x is greater than or equal to sine cube x, and so on. In this, the assumption is that sine x is positive, right? And in terms of at least absolute values, sine x would be greater than sine square x would be greater than sine cube x, and so on, right? And so as you go, the higher powers are actually smaller and smaller in value, but they will all be positive whenever you are taking even powers, right? So I can say that sine raised to 2nx will always be smaller than sine square x, and cos raised to 1x will always be smaller than cos square x whenever n takes the value, let's say 1, 2, 3, and so on. And so finally, when I add these two inequations, what I get is 0 less than or equal to sine raised to 2nx plus cos raised to 2nx, which is then less than or equal to sine square x plus cos square x. And we know this value, sine square x plus cos square x, is actually equal to 1. And therefore, your entire expression must lie between 0 and 1, whatever may be the value of n, correct? Okay. So you see, we have done another question which depends on n, but we are able to tell where this given expression always lie between simply by using the fact that sine square will always lie between 0 and 1. Got it? Okay. Let us proceed then. If sine theta 1 plus sine theta 2 plus sine theta 3 is equal to 3, then cos theta 1 plus cos theta 2 plus cos theta 3 is equal to what? Okay. Now, if you see, we know how to convert in general between sine theta and cos theta, right? Because we know two identities. We know sine 90 minus theta is cos theta, and we also know that sine square theta plus cos square theta is 1. But in this question, you have sum of three different terms is equal to 3, right? Which means none of those earlier identities would be directly useful. Because if I square this entire expression and try to convert to cos square, I will have a lot of extra terms, which is not at all helpful. So now, what we need to do is observe this question carefully. Just observe it, think about it. When you have sine theta 1 plus sine theta 2 plus sine theta 3, the sum is equal to 3. Focus on this 3. What does that tell you? See, do you know that sine theta is always less than or equal to 1? We know that, right? Which means if I add the sine values of three different values, do you realize the sum will actually be less than or equal to 3? All the three values must be less than or equal to 1. And therefore, when I add, the sum should be less than or equal to 3. But here, it has been given that actually the sum is equal to 3. If the sum is equal to 3, I can say the given relation is satisfied only when sine theta 1 is equal to sine theta 2 is equal to sine theta 3, which is equal to 1, right? Each of the terms must be equal to 1 because individually every term is less than or equal to 1. And so I can say that each of these terms is equal to 1. And when each of these terms is equal to 1, think about it. What happens whenever sine theta is equal to 1? Which is the angle that you know where sine theta is equal to 1? 90 degrees, right? As you proceed, you will learn about more angles. But right now with this knowledge, since you know sine theta is equal to 1 when theta is 90 degrees, what is cos 90? 0, right? So in general, whenever sine theta is 1, cos theta must be 0. You can also figure that out if you use the identity sine square theta plus cos square theta is equal to 1. So if sine theta is 1, cos theta must be 0. And therefore I can say cos theta 1 is equal to cos theta 2 is equal to cos theta 3, which is actually equal to 0, right? And so what happens to the sum? The sum is cos theta 1 plus cos theta 2 plus cos theta 3 is actually equal to 0. You see, often JEE asks you questions in which it is not simply enough to know the identities. It is not simply enough to be good with calculations. JEE also requires you to get that flash of inspiration. Just get that one brilliant idea that will save you so much time. You see, in this question, the idea that since each of these terms are less than or equal to 1, but the sum is 3, therefore individually they must be equal to 1. That is a very nice idea that will save you a lot of time. And such I would say it's actually epiphany. It's a flash of inspiration which will save you a lot of time and which will give you a lot of confidence in solving these questions. And for questions like these, you must be very calm. Only a calm and peaceful mind would give you these ideas, right? So you must also learn to keep your mind calm while solving problems. Okay, that is another skill that is found to be extremely helpful for JEE preparation. Okay. All right, so let's proceed. If the equation cot raised to 4x minus 2 cosec square x plus a square is equal to 0 has at least one solution, then the sum of all possible integral values of a is equal to what? Okay, You see, in this question, not only we have trigonometric ratios like cot x or cosec x, we also have a number a square. So we are going to combine our knowledge of trigonometry as well as quadratic equations. Okay. All right. So it is given that cot raised to 4x minus 2 cosec square x plus a square is equal to 0. This cosec square x, I can write it as 1 plus cot square x, and therefore cot raised to 4x minus 2 times 1 plus cot square x plus a square is equal to 0. That is, cot raised to 4x minus 2 cot square x plus a square minus 2 is equal to 0. Now, look at this expression, cot raised to 4x minus 2 cot square x. Does it ring a bell? Can I say this looks like p square minus 2p or t square minus 2t, where t is equal to cot square x. So if you have an expression t square minus 2t, what does it tell you? How can I simplify that? Can I make use of that form? See, t square minus 2t, if I simply add 1, it becomes a perfect square, right? So if I add 1 over here, I will have a perfect square, but I have to make sure that I subtract it later. And therefore, adding and subtracting 1 gives us cot raised to 4x minus 2 cot square x plus 1 plus a square minus 3 is equal to 0. Why have we done that? Because then the first three terms become a perfect square, which is cot square x minus 1 the whole square. And that a square minus 3, if I take it to the RHS, I get 3 minus a square. Right? So cot square x minus 1 the whole square is equal to 3 minus a square. And therefore, to have at least one solution, your RHS 3 minus a square must be greater than or equal to 0. Why? Because you see, cot square x minus 1 the whole square, it is a perfect square. Therefore, it must be greater than or equal to 0. Therefore, I can say 3 minus a square is greater than or equal to 0. Therefore, I can say a square minus 3 must be less than or equal to 0. Right? Because I have reversed the two terms. And therefore, a square minus 3 is less than or equal to 0, which can only happen if a lies between minus root 3 to plus root 3. Right? I hope you know how to solve inequations like these. Right? So I can say a square is less than 3 and a square is less than 3 only when a lies between minus root 3 and plus root 3. But the question asks us sum of all possible integral values of a, right? Integral values. So within this interval, what are the integral values of a? It is minus 1, 0 and plus 1, right? Minus 1, 0 and plus 1 are the integers lying between minus root 3 and root 3, and therefore I can say the integral values of a are minus 1, 0 and 1, and therefore their sum is actually 0, right? The sum of all possible integral values of a is 0, which is your answer. So you see, in this question, we use our understanding of trigonometry and also a very basic understanding of how polynomials work, of how if you have an LHS which is positive, then the RHS must also be positive. And then using our basic understanding of inequations, we have found out the integral values of A. Got it? Okay. So I hope apart from revising your basic formulae in trigonometry, you have learned some interesting new tricks and some more concepts have been clarified. We will be solving a lot more questions like these. All right, keep practicing. Bye.